Okay, so this is the normal distribution 2, and we need to think about, last time we watched the video, and if you didn't watch the earlier video, watch it, we looked at going between 0 and 1 about 0.34. We knew that. But now we're going to look at this idea of what happens if I've got my normal distribution. Here it is. Now this is what's called the standard normal, remember. So in the standard normal, the mean, mu, oops, I just wrote the wrong number, mu equals 0, okay, and sigma, the standard deviation, is 1. And if those numbers confuse you, go back and watch the first video. Okay, so what happens if I want to say, how about the possibility that x is greater than, the probability that x is greater than 1.3? How am I going to deal with that? Because when it was 1, we knew it was about 0.34, that was fine. So the first thing I'm going to do is draw my picture. It's the first thing I always do. Okay? So I'm just going to do my little sketch down here. I'll move my paper up. Okay, so I'm going to put my little sketch in here. Here it goes. Oh dear, that's a terrible sketch. There we go. That's 0. Sigma is 1, and we want 1.53 even. And so I want bigger than 1.3, so there we are, I've shaded it in. Now that's the picture I want. I cannot work that out. I can only work out this bit. This is the only bit I can work out. Alright, it's quite straightforward. Remember that. So the question is, if I knew that, could I work that out? Well, yes, I could, because I know it's symmetrical. So I know that this bit here is all 0.5. So once I've worked out this bit, I'll be okay. And to work that bit out, we're going to use a formula. And the formula says Z equals x minus mu divided by sigma. So in our case, that means that Z equals x. What's x? In our case, 1.3. It's the number we gave you. Okay? So, Z equals 1.3 minus mu. What's mu? What's mu? 0. What's sigma? 1. So consequently, what we have is that Z equals 1.3 in this case. Okay? Now that is not the answer to the question. Let's be really clear about it. 1.3 does not solve my problem. If you wrote 1.3 down in a probability exam, we'd look at you like you're an idiot anyway, because you can't have a probability of 1.3. You can't be 130% certain, can you? Okay, so now what we're going to do is we're going to use a standard normal table. Okay, and you get one of these in the formula sheet, and there's one of these in the back of your book. I'm using a big one just so we can see it easier. And here it is. Okay, it says normal distribution table. And look, the very first thing it does is it shows you the little shady area. Okay, that's to remind you that we can only work out this bit. Okay, and now what I've got in my table, I hope you can see. Okay, down here I've got some Z numbers. Across here I've got some extra numbers, which I'll show you what those mean in a moment. Okay, and in here are all the probabilities of getting between the centre and the Z number. Now we've worked out already that the Z number was 1.3, didn't we? So I'm going to look down my table until I find the number 1.3. There it is. You see that? Okay, I know it's a bit small. I'll tell you what, I'll zoom in just so you can see it on the thing. So here we are. This is 1.3. Now be understanding the fact that there's all these numbers across now that could be. This is 1.30. This is 1.31. This is 1.32. This is 1.33. This is 1.34, and so on and so on and so on. Okay? So the number I'm looking for is 0.4032. It's that number there. Okay? So I can now write down, I'm going to zoom out again. So when I go back to my sheet, remember, we now can say that the probability of that particular Z number is going to be, what did you say, 0.4032, I think we said? Yeah? Now, what probability is that? Is that the answer to our question? No. That probability is that space there. Okay, so I can now keep my arrow going all the way up and join it on. Okay, so that probability we've just worked out must be 0.4032. Okay, and that's how we do it. So we work out the probability of this space here, which means I now know the answer to my question is going to be 0.5, because it's half of it, isn't it? Take away 0.4032. Okay, and what that gives us, I think, well, I'm going to use my calculator just to be sure. So I've put my calculator into ordinary mode, and I'll just type into it 0.5 take away 0.4032 equals, and that's my answer, 0.0968. So the probability that x is bigger than 1.3 is 0.0968, and that's the answer to the question.